So in this video, I'm going to talk about the vSphere Web Services API and how to perform automation tasks on VMware products using this API. So let's take a look of the various things which I'm going to cover here. So first of all, we'll identify the function of an API or an application programming interface. Then we'll try to see what are the components of the vSphere Web Services API. Next, we will try to see how this API can be used for various automations tools. And finally, we are going to take a look at something called object-oriented programming, or the terms associated with the object-oriented API. So let's get started there. So what exactly is an API or an application programming interface? So API is basically for any kind of software. It's an interface for consuming the services provided by that piece of software or that piece of code. So I would like to think of an API is like a hook which kind of connects to the underlying software components and helps us perform various tasks. So the vSphere Web Services API is the central interface for automating the vSphere platform. So if you look at the figure here, we can automate the the vSphere platform using various tools like the command line interface, SDKs or software development kits, or the user interface itself. If you look a little deeper about how this API looks like, if you see down below, we have all these various components of the vSphere platform, or the various things which actually make up the vSphere platform. Like you have the virtual machines, you have ESXi hosts, you have switches, you have the data stores, and all these objects are maintained in the inventory of the vCenter server, which we can see here. And when we try to access these objects or try to perform some tasks on these objects, we use the various tools. Like we can use the actual web client or the HTML client, and we can use automation tools like PowerCLI or even vRealize Orchestrator. So this is how fundamentally we access the the vCenter inventory using these tools, and the interface is the vSphere Web Services API. So what are the different things we can do with the this API? So anything and everything can actually be done using the application programming interface, which includes your taking your the inventory of your infrastructure, authentication and authorization, that means logging in, logging out, etc. Then we have host management, storage management, networking. So basically you're managing your ESXi hosts, managing the distributed switches, or managing your networking or your data stores. Everything can be done using the Web Services API. We can also do the virtual machine configuration, including creating virtual machine, changing the properties of a virtual machine. We can manage the virtual machine, like starting or stopping a virtual machine or taking a snapshot. We can do vApp management, like deploying vApps from OVF template. We can perform resource management, like your resource pools, etc. We can even work on the tasks and schedule tasks. We can work on the events and alarms, and we can also pull out data about the vSphere performance. So these are all the things we can use the vSphere Web Services API. We can perform these tasks. So let's now try to understand a key concept called the managed object and the managed object ID. So a managed object is a component residing in the vCenter inventory. So everything which is part of your infrastructure, like an ESXi host, all your virtual machines, all your data stores, switches, etc., they are all objects in the vCenter inventory or the vCenter database. However, to access those objects, we need a reference point. So this reference mechanism is provided by something called the managed object ID, also called the MOREF. so, or the managed object reference. So this is basically an ID which is unique for each and every object. So if you see here, the client side applications like your PowerCLI or your vSphere client, they refer to these objects using the managed object ID. So the managed object IDs are very important, and we'll see them in action in the next slide. So now let me just introduce a term called object-oriented software or object-oriented programming technique, which basically is a layer of abstraction which helps your software developers to be able to write software easily without actually knowing what is the inherent complexity inside the software itself. So let's try to understand, or let's try to compare this with a real world example. So let's say that your car is an example of object. So let's say that the car is an object, and in the software world your virtual machine is an object. So I'm just doing a comparison or analogy there. So now all objects have something called properties and methods. So the property of a car will be something like how many doors does the car have, or how many wheels does the car have, or which door, is it door number on the left, or the door on the right, or the door on the rear. In the similar way, in the software world or in the vSphere world, the name of the virtual machine, like in this case my VM, this is a property of the virtual machine. So I'm just trying to compare it with the example of the car. Similarly, there is something called a method. So method in terms of a car would be something like open the window or press the accelerator. These are all methods which performs an action. Similarly, in the vSphere world, a method would be something like power on a VM, or taking a snapshot of a VM, or maybe power off a VM. All these will come under the category of a method. So method, as the term indicates, is something which performs an action. So when you invoke a method, or when we try to do something to an object, we need to specify the parameter. So for example, when you say open a window, so you need to specify a parameter called, okay, open the rear window, or open the left side rear door. So these are called parameters, which points to a particular component of that object. So in the vSphere API, if you say put a host in maintenance mode, then the parameter would be the name of that particular ESXi host. So let's say that put the ESXi host 3 under maintenance mode. So that is called a parameter. So I hope now we understand a little bit about what this object oriented terms are, and what an object oriented software technology looks like. So in this slide, we are going to see the properties of actual managed object, which is a virtual machine. So we are looking in the managed object browser, and we are looking at the properties of this virtual machine, whose managed object ID is VM212. So this is basically the managed object ID of that particular virtual machine. And we are looking at the various properties of that virtual machine. So if you see, there is we are at the page which says properties, and if you look at the properties, there is a property called data store. And on the data store property, we see that this virtual machine is on data store 45, which is basically this data store SA-shared-01. This virtual machine is on this particular data store. So using the properties, we can get a lot of information about a particular object. For in this example, it is this virtual machine. So what we saw so far was just a few properties of the virtual machine objects. But if you want to know about all the properties of a virtual machine, or about all the properties of the different objects in the VMware infrastructure, then you might need to take a look at the documentation. The documentation for the API is available at this page. So the link is provided in the slide here. So for example, here we see documentation about the properties of the virtual machine. So here you can see each and every property, and you can also find out what are the methods which are associated with the virtual machine objects. So in review, what are the things we learned about the vSphere Web Services API? So we identified the function of an API. So basically an API is nothing but a kind of a hook or a kind of a lever which allows us to connect to the software components which are inside that particular software. We looked at the various components associated with the vSphere Web Services API. And we also saw how we can use the vSphere Web Services API with the various automation tools like PowerCLI or the vRealize Orchestrator. And we also understood a few things about object-oriented programming, or the object-oriented nature of the vSphere API. In this video, I'm going to talk about the VMware Managed Object Browser, which provides an easy or user-friendly way for us to discover and look at the vSphere object model. So what are the things we are going to look at here? We'll see use the Managed Object Browser to explore the vSphere object model, and we'll also see how to invoke certain methods on the various objects. For example, how to invoke a power on a virtual machine using the Managed Object Browser. How do we access the Managed Object Browser? So it is relatively easy. You just have to open your web browser and point it to your the FQDN of the vCenter server, which is shown here. So you'll have to start with HTTPS because it's a secure channel, and type in your vCenter server FQDN /MOB, which stands for Managed Object Browser, and it will open a web page showing the contents of your the vCenter hierarchy. So basically, when we launch the Managed Object Browser, it is accessing the vCenter database using the vSphere Web Services API. So as we can see here, the vSphere Web Services API is the actual the interface or the connection mechanism which is allowing us to access the vCenter database or the vCenter inventory. We are pretty much all familiar with how the vSphere client looks like when we launch the vSphere client to work on our the various objects inside your vSphere environment. You often see something like this, where you have the data center folder at the top with the data center name, and then you have various subcategories like the virtual machine folder, the host folder, the data store folder, or the network folder. Similarly, when we open the Managed Object Browser, it presents you with a view which is similar to that, but not exactly the same, because this is not that user friendly like the vSphere client. Here you start off with something called the service instance, which is the starting point, and then we go to the data center folder, followed by the data center and the similar child items, whatever we see in the vSphere client. So what are the characteristics of this of this API model, or how do we look at it? So the structure is very similar in the vCenter server as well as the ESXi host. They look very similar. The ESXi host, however, presents a subset of this hierarchy. So you can connect your Managed Object Browser directly to your ESXi host and look at the components there. And the HTML client or the vSphere web client actually gives you a very user-friendly view into the same inventory. So when you are looking from the vSphere client or the vSphere web client, you see the same objects in a more arranged in a more user-friendly fashion. So here I'm just showing an example of accessing a vCenter inventory with the managed object browser. So as you can see, the first starting point or the place where it takes you when you first launch the MOB is the service instance page. So if you see here, this is the service instance page, and under that you will have an option called the contents. So once you click on the contents, you will get to get to see the other parts of the inventory. So here I'm navigating through the managed object browser, and after going through the content, you will see something called data centers, as we saw in the hierarchy in the previous one of the previous slides. So here the data center is denoted by this group -D1, and once you click on the group -D1, you will go to the the next items in the hierarchy, which might include your virtual machine or your hosts or your data stores and the switches. Everything can be accessed here. Here we see some of the things which you can actually do with the managed object browser, and one of the very important things is invoke methods. So what is a method? Method is basically any kind of operation or action you perform on an object. So for example, in the case of a virtual machine, you have these methods available like mark as template, migrate virtual machine, power off virtual machine, or reconfigure a virtual machine. These are the methods available for a virtual machine. Similarly, every object in the managed object browser inventory will have its own methods where you can perform various tasks on them. So if you want to invoke some of the other methods, or if you want to know what are the various methods available for a particular object like a virtual machine, you'll have to look at the documentation page. So the documentation page link is provided here. So once you go to this particular page, you can look at all the methods and properties. For example, here I'm looking at the methods of a virtual machine object. So as you can see, there is a huge number of methods which are available for a virtual machine. So all these are methods of a virtual machine. This means all these are tasks which can be performed on a virtual machine object, and one of these tasks is the power on VM. So the power on VM, which is highlighted here, is one of the tasks. One word of caution here, you should not be performing any action on the virtual machine using the MOB, or you should not be invoking any methods without knowing exactly what it does. So the best practice is to read the documentation thoroughly and then go ahead and invoke a particular method. And usually invoking a method is not something which is done by an administrator. It is usually something which is done during troubleshooting by the vSphere support services. The support personnel can do it for troubleshooting purposes. So now that we have seen the documentation on what are the various methods which are available for a virtual machine, and we understood what each and every method does, then we can now try to invoke one of these methods. So invoking the method is a relatively easy task. You can just go to the this page for that particular object. For example, here I'm in the managed object browser. I'm going to the properties of the VM39, which is one of the virtual machines in my environment, and on that page you will get an option called the methods. So here we see these are the methods which are available for that virtual machine, and I'm going to invoke a method called the power on VM. So to invoke the method, you simply click on this hyperlink called the power on VM tasks, which will launch another window, which is the power on VM method window. And in this window, you will find an option called invoke method. So invoking this method, once you click on the invoke method, this will basically power on the VM. So this is how you invoke the method on any kind of object. In our example, we are invoking the power on method on the virtual machine. So what did we learn so far? We looked at the managed object browser and how we can use the managed object browser to explore our vSphere inventory, and we can pretty much see everything which is inside the vCenter database using the managed object browser. And we also saw how to invoke methods using the managed object browser. As I said, a word of caution there: before invoking any method, we need to understand what exactly the method does. And for this, we need to look at the documentation of that particular method, and the documentation links are also provided in your course material. In this video, I'm going to talk about PowerCLI, what exactly is PowerCLI, and how is PowerCLI related to Microsoft PowerShell. As you might be aware already, that Microsoft PowerShell, or Windows PowerShell as it is popularly known as, it's a programming language developed by Microsoft, which is primarily used for automation related tasks. This programming language has been used by many other vendors to write their own code for automating their own environments. So one of the implementations of Windows PowerShell is VMware PowerCLI. So VMware PowerCLI is a kind of a automation environment, or a scripting environment, which has been created by VMware using the Microsoft PowerShell programming language. So if we do a side-by-side comparison of Microsoft PowerShell and VMware PowerCLI, so let's see what are the features which are similar and what is different. So if you see Windows PowerShell or Microsoft PowerShell, it's a command line and scripting environment. PowerCLI is a set of modules which is developed by VMware to automate the VMware products. Now the language used here is nothing but PowerShell, so that is something to be kept in mind. So the syntax is exactly the same. So the commandlets, which are the commands in Microsoft PowerShell, they are called commandlets, and the commandlets use a very consistent syntax. So they always come in the form of a verb followed by a noun. So in the same way, the PowerCLI commandlets also follow the same syntax. For example, start VM. So start is a verb and the VM is a noun. PowerShell or Windows PowerShell uses the .NET object model, and which is the same thing which is used by the PowerCLI as well. So it uses the same object model in the backend. PowerShell or Windows PowerShell is used by administrators to automate a Windows platform or Windows related or Microsoft related products, and PowerCLI is something which is used by VMware administrators to automate VMware products. So if we look at the architecture of PowerCLI, PowerCLI uses the vSphere Web Services API. So vSphere Web Services API is the interface which allows external tools like PowerCLI to connect to the the vCenter database and to perform various tasks on the VMware products. So this API is very important. So as you can see in the figure here, all the connections are done through the vSphere Web Services API, and it doesn't matter whether you are connected to the using the vSphere HTML client or the web client or PowerCLI or other automation tools like vRealize Orchestrator. All of them connect using the vSphere Web Services API. What are the different VMware products which can be automated using PowerCLI? So pretty much a large fraction of the VMware products have already got PowerCLI modules. A few examples are the update manager, the ESXi image builder, auto deploy services, we realize automation, we realize operations manager, vSAN, VMware View. All these have their own PowerCLI commandlets. So what are the advantages of using PowerCLI? So PowerCLI provides certain advantages than using the graphical interface. For example, it reduces the operating expenses, enabling you to focus on strategic projects. So instead of an administrator doing all the manual tasks by himself and spending a large amount of time using the user interface, he can automate most of the tasks using the PowerCLI scripts, and he can focus his efforts on adding value to the other projects. It helps in maintaining consistency and ensuring compliance. So for example, you want to apply a policy across a large number of virtual machines, or you'd like to make a configuration change across hundreds of virtual machines. It can be done very easily using PowerCLI automation rather than doing it manually from the user interface. And so in this way, it reduces time spent on performing manual and repetitive tasks. In this video, I am going to show you how to install PowerShell and PowerCLI for automating your VMware environment. So to install PowerCLI, first we need to install the PowerShell on your computer. So a few years back, Microsoft has open sourced PowerShell as a programming language. So PowerShell is now available on multiple platforms, which is not only Windows, but it's also available on Linux and Mac OS X. So let's try to see how we can install PowerShell on these various platforms. So to install a PowerShell, first you must download the appropriate package from this website, which is an open source website, inside GitHub. So you have to go to this link, and in this link I am trying to download the Windows package for PowerShell, so which comes in the form of MSI package. So you can go ahead and download the Windows 64-bit version package from this website and install PowerShell on your laptop so that you can use PowerCLI. In case if you are using a Mac or a Linux system, then there is a package available for these as well. So in this screen, we are seeing that we are downloading a package for Mac OS X. So this package is available here, and you can download and install the OS X package if you have a Macintosh system. After you have installed PowerShell, it is very important you check that it has been properly installed and you have the latest version which is required for installing VMware PowerCLI. So for using VMware PowerCLI 10, which is basically the latest version of PowerCLI, you might need the latest version of PowerShell, which is version 6. So here I'm running this command called $PS version table, and if you run this particular command, you will get the version of PowerShell which is installed on your system or on your laptop. So here I can see that the PowerShell version is 6.0.2, which is good for installing PowerCLI 10. After you have ensured that PowerShell itself is installed on your computer, then we will try and install VMware PowerCLI. This is very easy to do. You just have to run one command, which is install module vmware.powercli. This is a commandlet which you need to run. So basically the commandlet is install module and the parameter is vmware.powercli. So for this, of course, you need to be connected to the internet, because the packets will be downloaded from the internet and installed on your computer. So once you launch this command, you will be given an option where you have to say yes or no for downloading those packages, as can be seen here. So if you say yes to all, it will download the relevant PowerCLI packages. Once you have installed PowerCLI, we must verify the installation. To verify the installation, simply type in the command get module minus name, and you just specify what module you are looking for, which is in our case is anything starting with VMware. So I have put it as star VMware star, and it gives me a list of the modules which have been installed on my system. And we have the latest version of PowerCLI 10.1 installed on this computer. Starting with one of the recent releases of PowerCLI, the certificate handling has been slightly changed. So when you try to use PowerCLI to connect to vCenter or ESXi, it might give you a certificate related error. To prevent this issue from happening, you might need to change the certificate handling by using the commandlet shown here. So you simply put in set PowerCLI configuration hyphen invalid certificate action and set it to ignore. So basically this will make sure that you do not, even if you get any certificate related errors, those errors will be ignored. So it's very important to do this before you start working with PowerCLI and connecting to different to your vCenter or any ESXi hosts. As we mentioned earlier, VMware has designed its own modules for PowerCLI, which are basically written in the PowerShell programming language. So it's very important to understand what exactly is a module, because the module is the thing which provides you with all the functionality which you use for your automating your VMware environment. So what exactly is a module and what it consists of? So PowerShell modules are a set of related PowerShell functionalities grouped together as a convenient unit. For example, you have a separate module for vSphere automation, or for maybe vRealize automation you will have another module, or maybe VMware View you will have a separate module. So these are packaged together as different modules, and they are all packaged in a particular way or a certain way these files are structured. It consists of something called a .psm file. .psm file is actually the file which contains all the functions in your module. So all your module functions are contained in the .psm1 file. And you also have a manifest file, which is basically a metadata file which provides you a description of the module. So these are stored in a file ending with the extension .psd1. So the .psm1 file and the .psd1 file, those are the very important files which constitute your module. Other than that, in the module folder you will find other files like assembly or help files. And all these are contained in one directory and the directory will have the name of your module. So let's take a look at how it looks like. So here you can see that these are the VMware specific modules which are installed on this computer. So everything starting with VMware is here. So you have vmware.vimautomation.core. And if you open any of these module directories, you will see a very similar structure in all these module directories. So you will see a PSD1 file and a PSM1 file, which I described earlier. So one of them is your is the file which contains all your functions for that module, or all the actual good things which are provided by that module. And the other one, the PSD1, is actually kind of a manifest file which describes that particular module. In this video, I am going to talk about the PowerCLI syntax. So every programming language has a particular syntax which you can think of like the grammar of that language. So the commands or the commandlets in the case of PowerCLI, they have to be written in a particular format, and they have to follow a particular grammatical site. That is what is referred to as the syntax of a programming language. When it comes to PowerCLI, it has a very simple syntax, and it is exactly same as Windows PowerShell. So all commandlets in PowerCLI comes in this format, which is a verb followed by a noun. So if you look at the example here, get VM host is one of our commandlets, where get is a verb and the VM host is the noun. So all PowerCLI commandlets need to follow the same kind of pattern, which is a verb followed by a noun. The other things to be kept in mind is these terms called parameter and argument. The parameter in this case would be particular aspect of that object which we want to look at. For example, when we say get VM host, which virtual machine host do you want to look at, and how do you identify that host? So for that we need to specify a parameter called name. So let's say that get VM host hyphen name is the parameter, and the argument is the actual name of the host. So the parameter will be the word name, and the argument which will be the name of the ESXi host, let's say ESXi01 or ESXi02. So it is very important to differentiate between a parameter and an argument. Let's take an example of connect connect VI server syntax. So to connect to your vCenter server, we use a commandlet called connect VI server, and here we are using a parameter called server. So which means that after this parameter we must specify the argument as the FQDN of your vCenter server. So the server is the parameter and the argument is your FQDN of your vCenter server. Next we have to specify the username. So the parameter here is -user, and the argument is the actual username, which is nothing but administrator@vsphere.local, and the next parameter in the list is -password, and the actual argument is the password, which was the password specified here. So this commandlet will basically connect you or connect that particular session to the vCenter server, and once you are completed your tasks or you want to disconnect from the server, you can simply type in disconnect-vi server without any parameters. So the way of connecting we saw earlier is not very useful if you are writing a script. So you don't want to specify the username and password each and every time in a script. Here we can use another feature of PowerCLI called a variable. So what exactly is a variable? A variable is a kind of a placeholder which stores a value. So just like you might recall in algebra, we have variables like x, y, z, and they stand for different values. So in the similar way, in programming languages like PowerCLI, we can use variables, and the catch is that each and every variable should always start with a $sign, which is part of the syntax. It's a requirement. So here in this case what we are doing is we are using a variable called vCred. So basically what we are doing is we are using a commandlet called get credential, and we are storing the the information in this variable called vCred. So vCred is now going to store the credentials which are required to log into the environment. So I ran this command get credential, and I stored the resultant information in vCred. In the next step, I am going to use the vCred variable to connect to the vCenter server. So as you can see here, this helps me avoid typing in the username and password again and again while connecting. So you simply store the connection the credentials into a variable and pass in the variable into your script, and that should work each and every time. So let's take a look at the different types of commandlets available in PowerCLI. So the PowerCLI commandments, as I already said, that they all come in the verb noun syntax. But there are different types of these commandlets. Like we have something like a get VM, which will get you information. So the get commands are pretty safe to use because it just gives you the information of that object. So it can be a get VM, it can be a get data store, it can be a get VM host. So it will just get you the information. Then you have a commandlet like new VM, so which will basically, as the name suggests, it will create a new virtual machine. So you have new VM. So this commandlet will make changes to your environment. So let's keep that in mind. So if you are using this commandlet starting with new, you have to be careful while using it. Next, we have a type of commandlet which starts with the set command. So here I'm using an example of set VM. So basically, a set VM can be used to change the configuration of a virtual machine. Again, this commandlet will make changes to your environment, so we have to use it with caution. Then we have another type of commandlet, like let's say a move VM to relocate the VM to another host, like do a vMotion. And we have a commandlet like a remove VM, which will basically delete the virtual machine. So all these commandlets have to be used in caution because they will make changes to your environment, and if they are used as part of a script, they might cause a lot of damage in case if you are if your script has something which is incorrect, or it is doing something which it is not supposed to do. So among all these commandlets, only the get VM commandlet is pretty harmless to use. It will not make changes to the environment. So as I mentioned earlier, that you can use the connect VI server and the disconnect VI server to connect or disconnect to your vCenter systems. And if you don't want to type in your username and password each and every time, then you can go ahead and store the credentials into a variable and use it in your script. Okay, so now let's take a look at one particular commandlet and how we can use this commandlet with various parameters to get the information which we need. So I'm using a commandlet called get VM host, and I run this commandlet without any parameters. So when I say get VM host without any parameters, it will show me all the hosts in my environment. So you have all the hosts in my environment, and it will show the various properties of those hosts, like whether they are powered on, whether they are in the connected state, or what is the total memory size, the version of ESXi installed. All this information will be displayed. However, it is most of the time we don't want to see all the information in the inventory. We want to look at only one particular host. So that is where the the parameters prove to be useful. Here I'm going to specify the name parameter, and I'm going to specify the name of one particular ESXi host. So I type in get VM host minus name and the name of the ESXi host, which gives me information on one host only. You can imagine, if you have, let's say you want information on virtual machines, and you have let's say 500 virtual machines. You don't want to see the display with the output of all the virtual machines. You want only the virtual machines you want to look at. So here your parameters will be useful. Now I'm just going to talk about this something called positional parameters. So when we say positional parameter, it simply means that in certain cases we do not have to specify a parameter at all. For example, when we say get VM host, PowerCLI is expecting that in the next after get VM host, you are going to type in the name of a host. So we do not need to specify the name parameter here, because PowerCLI will just assume that you are going to type in the name of a host. So here I'm just saying get VM host with the name of a host. I am not using the name parameter, and it will give me the same result. So this is what we refer to as a positional parameter. There can be lots of parameters associated with each and every commandlet. So it is not possible for the administrator to remember all those parameters. So for getting the particular parameter which you want to use, it is very important to look at the help option which is available for each commandlet. So now that we know what information we need out of a particular commandlet and we can narrow it down using the parameters, it is very important that we get the output in the format we need. So now most of the time it is not very useful to have the the output displayed on the screen. We might want to store the output in a HTML file or a CSV file. So we can use some of these commands to produce the output which we actually need. So for example, we have a commandlet called convert to HTML. So basically we get the output which we want to get from that particular commandlet, and we can store it in the form of an HTML file, or we can use the export CSV commandlet, and it will basically export it to a CSV file, and we can use that CSV file maybe to generate a report in Excel. So all these formats are also available using the PowerCLI commandlets. So as I mentioned, one of the very important things to know is the different parameters which are associated with a particular commandlet, and how we can use those parameters in the correct way to get the particular output we need. To get that information, the easiest way to do it is the get help command. So in this slide we see that we can type in get help for any particular commandlet. In this case, I am running a get help on the get VM commandlet. So I type in get help followed by get VM, and it gives me the help or the manual on the get VM command. So it gives me what parameters I can use, how I can use them. So basically all the information which is provided by the documentation itself is also accessible here. Another very useful feature of PowerCLI is the examples feature. So if you say get help for a particular commandlet, in this case I am saying get help for get VM and show me the examples. So I just type in -examples. So it will basically show me some examples on how to use the get VM commandlet. So this is very useful in cases where you don't know exactly how to use a particular parameter, or how to pull out a particular piece of information like memory, maybe the memory information or the CPU information of a virtual machine. It is very useful to have some examples handy, which is provided by the get help get VM with the examples parameter. Few of the other important parameters which are available to us while using PowerCLI is we have something called what if. So what does what if do? Let's say that you want to perform a task which is very critical. Let's say in this case what I'm trying to do is set VM for a particular virtual machine, and I'm changing the memory to 2 gigs. So in this case, what I'm maybe not sure that whether I want to change the memory, or before I run hit the enter button, I want to make sure that I'm not running an incorrect command. So in this case, I just want to specify the what if parameter. So it will basically show me what will happen if I run this commandlet without actually running the commandlet. So if you're not really confident about running a particular commandlet and you don't know whether it's going to cause some problems in your environment, you can use the what if parameter. So this is pretty much useful when in cases where you kind of run into these kind of situations. Another similar example of this kind of safety mechanism is the confirm parameter. So basically if you use the confirm parameter, even after you run the commandlet and press enter, it will ask you whether you actually want to run it, and if you say yes, it is going to go ahead and run it. So the what if and the come or the confirm, these are the two parameters which you can use in case where you have doubts about running a particular commandlet. So how do you know which commandlets are available in a particular release of PowerCLI, and I mean, how exactly to use them? I mean, it's not possible for an administrator to remember or memorize all the commandlets. So the best place to go to is the command reference guide. So the command reference guide keeps on getting updated with each and every release, and it is now available on code.vmware.com. So if you go to code.vmware.com and look at the commandlet reference, you can look at the commandlet reference for a particular release of PowerCLI. So here I'm looking at this reference guide, and here you can search for any commandlet which you don't know how to use, or probably you want more information on that particular commandlet. Finally, these commandlets by themselves are not going to be very useful to you if you do not put them in some form of script which is going to perform changes across a large number of objects in your environment. So to do changes to a large number of objects, you have to write a script and save that file in a particular extension. So the PowerCLI scripts have to be saved in an extension called .ps1 or .ps2. Both of them will work. So the file should end with that extension. And once you have saved all your commands in a script and saved it in a .ps1 or ps2 extension, you simply can run that file from the command line. Simply give the name, full name and path of that file, and it will execute that script. So basically this will be very useful if you want to make a number of changes in the environment, or you want to perform a sequence of steps and you don't want to write each and every command and execute them one by one. So you just want to put them in a script and maybe execute the script which will make all the changes you want in one shot without you having to execute each commandlet one at a time. So that is the way where in which we can perform large scale automation in your VMware environment. In this video, I am going to dig a little deeper into the syntax of PowerCLI, and we are going to learn a few new terms like what are objects, properties, methods, etc. So let's get started. So this is what we are going to cover. We are going to describe the features of something called the command pipeline. We are going to examine PowerCLI objects, and since PowerCLI is an object-oriented programming language. And then we are going to learn some new terms like what are the properties of an object, or what are the methods associated with an object. So let's first look at this term called the command pipeline. So PowerShell and PowerCLI has this very useful feature where we can take the output from one commandlet and use it as the input for a different commandlet. So this allows us to create a pipeline or pipelines where we can have multiple stages in the pipeline. So let's take a look at an example here. We are running a command called get VM host, and get VM host as you know will produce the output as a ESXi host object. So basically we take the output of the get VM host command and we are piping it in. So we use the pipe symbol here to pipe the output onto a different command. So the next command we are using is format list. So basically we are inputting the output of get VM host and taking it and putting it as an input for the format list command. And here on the right hand side we see the final output on the screen. So this is a very useful feature in PowerCLI, which allows us to, use one command and pipe it into another command. So, or pipe the output into another command. So let's now take a look at a longer example of a pipeline or a slightly more complex pipeline. So here we are using the same commandlet, which is get VM host, and I'm using this pipe symbol here, and I'm piping it over to another commandlet called where object. Basically, the where object commandlet is used as a filtering mechanism to the filter the particular piece of information which you're looking for. So here I'm using the where object along with a condition which says if the power state property of that object is says powered on, then only select those objects. So a few important things are there to consider in this syntax. First of all, there is this particular syntax in PowerCLI called $_. So the $_ simply represents the current object in the pipeline. So here the current object in the pipeline is a VM host object. So we are taking the power state property of the virtual machine host object, and we are filtering it to say that show me only the objects which are or the hosts which are powered on. So this is basically the example of a longer version of a pipeline, and you can see that without the pipeline it would be very difficult to accomplish this task. So I hope by now you realize the the importance of the having this pipeline construct. There is another very important commandlet which I would like to talk about here, which is the get member commandlet. So what does the get member do? So basically the get member commandlet will show you all the properties and methods of an object. So for example, here I have an object of type virtual machine, and I have stored it in a variable called VM1. So $VM1 contains a virtual machine object. Now using the pipeline, I pipe in the virtual machine object into get member. Now when you run get member, you'll see a large number of methods and properties which are associated with the virtual machine object. So in the coming slides, we'll see what is the importance of these properties and methods. So before I talk about more about the virtual machine or the PowerCLI related properties and methods, let me talk about a generic case. So let's assume that your car is an object, and one of the properties of the car object would be body color. So let's say your car is red or maybe it's black. So basically the property is called body color, and the value of the property can be red, black, blue or gray, whatever your car color is. So basically your car is the object and the body color is the property. On the other hand, if you talk about methods, so method always represents an action which is to be performed on an object. So in the case of a car object, accelerate will be a method. So basically when you say I'm invoking accelerate, so it means the car will go faster or it will move forward. So basically this is the fundamental difference between a property and a method. So for our use in terms of PowerCLI, we are going to focus more on properties rather than on methods. So let's take a little deeper look into the properties. Each property, as you might understand, that it represents a property of that particular object, which in this case is the virtual machine object. So here I am basically saying by this command, get member and member type is property. So which means that I only want to see the properties of the virtual machine object. I am not interested in seeing the methods. So I'm basically restricting the output to only the properties. And you can see that there are a lot of properties which are associated with a virtual machine object, but this is also a truncated list. So basically I cannot fit the output on this screen. So there are a lot of other properties associated with a virtual machine. So as you can see that every PowerCLI object will have a lot of properties which are associated with that. Okay, so one more important thing which I want to point out at this point is that the properties of an object can be a simple string or a number or an integer, but the property itself can be another object, which means that in PowerCLI, the properties are nested objects. So that means that the property of a virtual machine might be another object which might be having its own properties. Now I'm going to show you an example of such nested properties. So let's see. We have an object of type virtual machine, and that object is my VM. It is stored in my VM variable, and it has a property called guest. So I'm looking at the property called guest of the my VM virtual machine, and you see that it has a lot of its own properties. Now one of the properties of the guest property is called disks. That means guest is itself a property, and it also has its own properties, and one of those properties is disks. And in the next line, I am actually looking at the properties of the disks property. So if you see that this is a nested hierarchical structure which goes deeper until we reach the the end of the tree. So finally I am here looking at the property of the disks, and we see that it also has its own properties which are associated with that particular property. So as you can see that the objects themselves are complex structures which have properties, and inside them there are more properties. So this is something to keep in mind when we are working with PowerCLI objects. So let's see that you want to look at some specific properties of an object. So let's see how we can filter those properties. So here I say that get VM VSA VM1. So VSA VM1 is one of the virtual machines in my environment, and then I pipe it to the select object commandlet, and using select object I select only one property, which is the ID. So basically I am selecting the property called ID, which is associated with a virtual machine, and it shows me the ID of the virtual machine, which is virtual machine -VM 220. So just to put this in perspective, this is the same ID which you are going to kind of see in the managed object browser if you try to look at this thing from the MOB point of view. So just to point out a relationship there. Okay, so now I'm going to use the properties to do some filtering, or basically I'm going to try to filter out certain properties of a virtual machine. So let's say I run this commandlet get VM, and I pipe it into the where commandlet. So I just say get VM and pipe it to where, and I say memory GB equals 4. So basically I am using the property called memory GB, and I am kind of comparing it to a particular number which is 4. So which means to say I'm trying to find out which virtual machine has 4 gigs of memory. So in my environment, I have this virtual machine called Win2012_unmap, and this is the only virtual machine which is assigned 4 gigs of memory. So basically this is a way of filtering out your data. So you can filter it using any of the properties like CPU count or the name of the virtual machine, or basically any other, or maybe which data store it is placed on. Using that property you can filter down the data, which is going to be very important when we start writing scripts and creating reports in PowerCLI. Finally we come to the methods of object. So basically when in our day-to-day work with PowerCLI, we don't use the methods frequently. We basically most of the time we use the properties, but we can also work with the methods if required. So for example, in this case, first of all, I take a virtual machine object which is stored in a VM1 variable, and I say get member where the member type is method. So if you recall, the last time we filtered it saying that the member type should be property. So now I'm saying member type is method, and it is showing me all the methods associated with that particular virtual machine. And then I am going to invoke a particular method called toString. So I just say VM1 toString. So basically it does a conversion and produces the string output of that VM name. So basically I get a string output which is basically text output of the virtual machine name. So this is just an example of the toString method. So again, as I said that PowerCLI has nested objects, so we can the methods can also be kind of it can become nested and it can be invoked at different levels. So we can have an object dot method which I'm invoking a method on a particular object, or we can go to a property of the object and invoke a method on the property of that object. For example, in this case, I am taking a data store. So vSAN DS is a variable which contains a data store, which is the vSAN data store. And what I'm doing is I am saying vSAN DS dot storage IO control enabled. Dot storage or storage IO control enabled is a property of the data store, and now I'm saying convert that output to string. So basically what I get is a false output, which means that the storage IO control is not enabled on this data store. So as you can see that you can invoke methods on an object, or you can invoke methods on the properties of an object depending upon what exactly you're trying to pinpoint or what you're looking for. Just another example of a method. So in the first line, we kind of look for a particular VM where we say get VM SAVCSA-01, and we do a get member where it returns all the members and all the methods and properties. And I am going to store that in a variable. So I'm storing that virtual machine in a variable called $vCenter VM. So vCenter VM now contains that virtual machine object, and then I am going to invoke a method on that object. So I'm saying vCenter VM dot VM host ID dot toString. So what it is doing is it is pulling out the property called VM host ID, so which means which host this VM is running on, and then I'm running this method called toString, and the final output is showing me that this virtual machine is running on host system -host -9, which is basically the managed object ID of that particular host. In this video, I'm going to talk about something called loops in PowerCLI. So if you're familiar with any other programming language, then you might also be familiar with this concept of loops. But why exactly do we need loops, or what is the use of these loops in the PowerCLI programming language? So let's say that you as an administrator is asked to power on one virtual machine. So what you're going to do is log into the vSphere client, and you are going to go to the the virtual machines and try to power on that particular virtual machine. Now let's say if you are asked to power on 100 virtual machines, or let's say 200 virtual machines at the same time, and let's assume that it takes you around 5 to 10 seconds to power on one virtual machine, or if you're doing it one by one, then it might take you as an administrator a very long time to accomplish that task. But if you are familiar with PowerCLI, and if you are using PowerCLI to do the same thing, then you can use a loop, and you can actually power on hundreds of virtual machines at the same time, just by repeating the task over and over again. So that is the primary function or the job of a loop, is to make a task repeatable. So PowerCLI, like any other programming language, has a number of different kinds of loops, like the while loop or the for loop or the for each loop. So let's take a look at some of these loops here. So one of the first type of loops which I'm going to discuss is the for each loop, which is the most commonly used construct in PowerCLI. So to use the for each loop is in PowerCLI is slightly different or unique than other programming languages. So let's take a look on how exactly we can use it. So before we can actually talk about actual PowerCLI example, I just want to clarify this using a normal PowerShell example where we are not using doing anything to your VMware environment. But let's take a very simple example of PowerShell and how the for each is utilized. So let's say I have three variables called A, B, and C. So $sign A, B, $sign B, and $C. Those are three variables. And what I say is $sign D equals A, B, and C. So D now contains, so D is called an array. So array D now contains three variables, A, B, and C. Now let's say that we want to increase the value of each of these numbers by 5, or put it simply, we want to add 5 to each of these numbers. So we use this loop called or this construct called for each. So basically for each goes through each and every member of an array and it performs an action on each member. So in this case, we are going through each and every member of the array by saying $sign I in D. So this is very important syntax to understand. This I here is called a placeholder variable, and the letter I does not have any meaning here, so you can call it anything you want. It can be X, Y, Z, M, N, O, P, whatever you want to call it. So $sign I in D is just a placeholder. So what it means is that each time I will assume the value of one of the members of the array. So as if you see here, D contains three members, A, B, and C. So each time I will assume the value of one of the members of the array, and it will increment by 5. So this is how the for each loop works. So this is a very important construct, which when you will see it in the next slide when we actually use it in PowerCLI. So let's look at an example. So just like we did with the numbers, so what I'm doing here is I'm saying my VMs equals get VM. So basically get VM will pull out the virtual machines in the environment. I am storing it in a variable called my VMs. So you have to understand here very clearly that my VMs is now being considered an array of virtual machines. So it does not contain one value, it contains multiple values. So it contains, let's say if I have 10 virtual machines, my VMs will contain all the 10 virtual machines in the form of an array. So next what I do is I just use the construct called for each, which we saw earlier, and we say for each $sign VM in my VMs. So as I'd like to reiterate this once more, the $sign VM is nothing but a placeholder, and it will assume the value of each member of that particular array, which is my VMs. So each and every time this loop runs, it will take the value of one of the virtual machines. So if I have 10 virtual machines in the environment, then this loop is going to run 10 times, and then it is going to perform the actions which is given here. So if the state is powered off, it will try to power it on, else it will just say that the VM is already on. So basically what I'm trying to illustrate here is the importance of the for each mechanism. So the for each mechanism allows you to kind of iterate through each and every member of a particular array. And in this case, this is the array called my VMs, which contains the virtual machines in our environment. So as I said, the VM is the placeholder variable. Now the $VM, of course, it does not have any significance in the name itself, so you can call it whatever you want. And as you can see that the final output, it shows that it has powered on some of the virtual machines, and the ones which are already powered on, it will say that the virtual machine is already powered on. So let me now talk about another kind of loop in PowerCLI, which is called the while loop. So previously we saw the for each loop in action. So while loop is another kind of loop which is going to help us perform repetitive tasks in a slightly different way. So as we saw earlier, in the for each loop, we can go through each and every member of a particular array of objects. But let's say that you want to perform a task n number of times. Let's say you want to do something 5 times or 10 times or maybe 100 times. So for that, one of the useful looping mechanisms is the while loop. So let's see how the syntax looks like. So here we see that we have created an array called A. So $A, the variable contains an array of these numbers 1, 2, 3, 4 and 5. And we have another variable called $X, which I have assigned the value of 0. So basically what this means, or what is the significance of this particular variable, is that it's a counter variable. So the $X is only going to do the counting here. So what I'm saying here is, while $X is less than a.count. So a.count is the number of elements in this array, which is 5. So the condition which I'm drawing here is, if the x variable is less than 5, then do the tasks below, that is increment each element by 5. And each time I am doing this operation, I am also incrementing the value of x by 1. So this $X plus plus indicates that I am adding 1 to the variable called x each time I run the loop. So what does this do? Each time I am going through this loop, x is increasing by 1, and eventually it will come to a point where x becomes equal to 5 or greater than 5, and at that point the loop is going to stop, because if you remember the condition of the loop is if x is less than a.count. So now I hope you are understanding how this works. So basically this is a mechanism where we use a counter, and we are kind of incrementing the value of the counter each time until we can end the loop. So let's take a look at an example of how we can use this in PowerCLI to do perform operations in the VMware environment. So let's say that we want to create, or we want to deploy some new virtual machines, and we have just kept in mind that we want 3 new virtual machines. So what I'm doing is, I'm creating a variable called VM count, and I set it the value of 3. So VM count equals 3. So now the VM count variable is containing the number 3, and then I use a while loop. I say that while VM count is greater than 0. So this loop is going to continue as long as the variable VM count is greater than 0. And the most important thing to do here is, each time the loop executes, or which means that each time we perform these operations, VM count is reduced by 1. So this line here which says $VM count minus minus, which indicates that VM count will be reduced by 1 each time the loop is executed until we reach 0. So once it reaches 0, the loop stops. So in the end, what we get is, we get 3 virtual machines which are created by this loop. So as you can see how powerful this mechanism can be. So instead of 3, you can just say 300, and it will create that many number of virtual machines without you having to, do anything from your side. It is just a looping mechanism which will keep on running the specified number of times, or whatever the number you have specified there. So let's now talk about another very common type of looping construct, or rather a logical construct called the if-else statement, which is pretty much common in most of the programming languages. So let's see how if-else statements work in PowerCLI. So let's take a look at an example here. So basically the purpose of this piece of code which we have here is to change the DRS automation level of a cluster. So basically what the code is going to do is to check if the DRS automation level is set to fully automated, and if it is not set to fully automated, it is going to set it to fully automated using the if-else statement. So let's see how this if statement is going to perform this task. So in the first line here, I say if my cluster dot DRS automation level is not equals fully automated. NE stands for not equals, and not equals fully automated. Here we are using a property called DRS automation level. DRS automation level is one of the properties of this cluster variable. So my cluster is your particular cluster where you want to change the automation level, and we are using this property called DRS automation level, and I'm comparing it to fully automated. If it is not equals fully automated, this if statement will make sure that only this part is executed, the part starting with the brackets here and ending with the brackets here. So only this part is executed. That means the first set of commands. Else, if we come to the else part, that means it is already fully automated. So let's say the DRS automation level is equal to fully automated. So in that case, this statement is not true. So just let me clarify this here, and it's very important to understand. Only if this statement is true, that is the DRS automation level is not equals fully automated, only then this block is executed, that is the first block is executed. If this statement is not true, then the else block will be executed. So the else block says that write a message saying DRS automation level is already optimal. So basically this is in the case if the DRS automation level is already set to fully automated, and it will execute this statement. So as you can see that if you want to perform some tasks based upon whether a particular condition is true or false, the best way to do it is using the if-else statements. Finally, we come to one of the more slightly complex looping or logical constructs in PowerCLI, which is the switch statement, which is also extremely powerful and useful when it comes to performing certain operations. So one of the beauties of the switch statement is that it can have multiple branches, which means that you can have a variable, and based upon the value of that particular variable or that particular condition, we can have n number of different tasks which are executed. So for example, we are here taking a variable, we are using the switch statement, and inside the switch statement you always need a variable for making a decision, and if that value of the variable is condition 1, it will execute one set of commands. If it is condition 2, it will execute another set of commands, and if none of these are, then it will execute a third set of commands. So let's see this in action here. So what I'm doing is I'm using this variable a as the condition. So basically, if you see in the switch statement, we need something for the condition, and we are using this variable called a. and based upon the value of that variable, we will perform various operations. So if the value of A says disconnected, it will execute these statements, that is write host not connected epic fail. If the value of the variable is connected, it will execute this statement, write host connected success. And if none of these conditions are met, then it will just say give an error. So basically for this particular piece of code, I have already set the value of the variable A to say connected. So when the value of the variable A is connected, it will just execute the block which says connected. So based upon the value of the variable, it will execute one of the statement blocks. So here I have just shown 3 blocks. But we can have a large number of different blocks where you can put maybe 10 different conditions, and you can execute 10 different kinds of statements based upon the value of that particular variable, which acts as the condition here. So in this video, we took a look at the different kinds of loops in PowerCLI, and like the for each loop or the while loop, the switch statement, the if else. So these are the various logical mechanisms or looping mechanisms which can allow you to create scripts where you can perform tasks on hundreds of different objects, like a large number of virtual machines, or perform a number of tasks on different hosts. For example, you can set 10 different hosts into the maintenance mode by just using one of these looping constructs. So as you can see that these looping constructs are very powerful, and when it comes to automating tasks, and it can really reduce the burden of the vSphere administrator. Hi, I am now going to introduce you to a concept called view objects, and I'll try to explain how view objects are different from the normal PowerCLI objects, which are also called VI objects. So let's take a look. So in this particular video, I am going to talk about a commandlet called getView, which is going to show us these view objects. We'll see how to convert view objects to VI objects, and we'll also see how to invoke vSphere Web Services API methods. Okay, so let me first try to explain a basic difference between a VI object and a view object. So if you're familiar with the PowerCLI commandlets, you might have seen that in PowerCLI we have a simplified representation of all the objects in the vSphere environment. For example, if you run a get VM, you get a virtual machine object. Using a get data store, we get a data store object, or we can use a get VM host or a set VM host, so where we work with the VM host type of object. So these objects are actually simplified representations of the actual API which is doing the work underneath, which is nothing but your vSphere Web Services API. So the vCenter inventory is exposed through the vSphere Web Services API. And when we run these PowerCLI commandlets, we are actually not dealing directly with the API objects, but we are dealing with the PowerCLI simplified objects, which are also called VI objects. But in certain scenarios or in certain cases, it becomes important that we or it is a requirement that we sometimes might have to work with the underlying API. We might have to make some changes which requires us to deal with this API level objects, which are called view objects. So these are the actual low-level API objects which are, controlled by your vSphere Web Services API. So if you look at the diagram here, we have the vSphere Web Services API, which basically, through the vCenter, it exposes all the vCenter inventory in the form of VI objects. For example, a virtual machine or a data store or a distributed switch or a VM host. So all these objects are exposed in a simplified way to the interfaces on the top layer. So these interfaces might be your PowerCLI or the vSphere HTML client. However, if you want to look at the actual the API level constructs or the actual objects which are controlled by the API in their raw form or without the unfiltered form, then you will have to use this, you'll have to work with the view objects. So if you look at the syntax here, using the get view command, we can get access to these view objects. So here in this example, I'm saying get view, and I'm looking at the type of objects of virtual machine, and I am filtering it using the name of the virtual machine, which is the web_server virtual machine. So this command will return the actual API level object representing that virtual machine. So which is called a view object, and it is not a VI object. So just a quick comparison between these two different types of objects. So if you look at the VI objects, which are the the high level abstraction, which is shown by the PowerCLI commandlets. So these are basically built for PowerCLI. So the PowerCLI utilizes these objects so that we do not need to see the internal nitty-gritty of how the actual objects are arranged within the inventory. So we can look at a more simplified and user-friendly view. These VI objects are returned by commands like get VM, and you can use commandlets like start VM. So these are the commandlets which we use day in and day out to control these kind of objects. However, when it comes to the actual API level objects, so these come under the category of the view objects, as I mentioned earlier, and this actually shows us the low level implementation. So we are actually dealing with the actual API, and this is the same things which we see when we open the managed object browser. So when we are dealing with view objects, you can just imagine that you are actually working with the same kind of stuff which you get access when you open the managed object browser. So these can be accessed using the get view, and we cannot use the normal commandlets like start VM on a view object. So these are the API level constructs, and the normal PowerCLI commandlets will not be compatible with the view objects. However, in the view objects, we have the option of directly invoking the methods of a particular object, or actually seeing the low level properties of the object. So you have to understand that it has a lot of power here. So we are looking at the actual low level implementation of the vSphere API, and so we can pretty much get access, unlimited access to the entire structure of the inventory. In this video, I'm going to show you how to use the get view commandlet to work with the view objects, which are the API level implementation of the vSphere objects. So let's look at an example here. On the left hand side, we are looking at a normal commandlet, which is get VM, which will basically return your VI objects. So I'm running this commandlet get VM on this virtual machine JEOS_test1, and we get output which shows us the virtual machine object which is also called a VI object. So these are the objects which we use with PowerCLI normally in our day-to-day operations. Now let's take a look on this screenshot here on the right hand side, where we say get VM JEOS test1, and we are piping that and piping it into the get view commandlet. If we pipe it into the get view commandlet, we get an entirely different picture. So basically this shows the underlying complexity of that object. So this is the API implementation of that particular object. So let's see further how we can use the get view commandlet to look at those objects in more detail. So the get view commandlets can be used for all the objects which are normally accessible using the PowerCLI commandlets. So for example, data center, host system, data store, resource pool, network, virtual machine, everything can be accessed using the get view commandlet. So now let's dig a little deeper into the properties of these view objects. So as I mentioned earlier, these view objects kind of show us the low-level API details of the inventory. Let's look at this example here. Here I use the get view command, and I'm using the syntax which I explained earlier, where I say view type is virtual machine, and I filter it with the name of this particular virtual machine, and I'm storing this output in a variable called VM view. Now the VM view of the object will obviously have a lot of properties. So just try to remember that this is not a normal VI object. This is a special type of object called a view object. So the view object will have different properties, and one of the properties of this view object is the config property. So I'm looking at this property. So I say vmview.config, which shows me this the config property. So if you look at the output below, you'll see that the config property itself is a complex object, and it has a lot of its own properties. So we'll dig a little deeper into the config property, and we'll see which are the properties which can be useful to us to pull out more information about that virtual machine. So here I am looking at a property called vmview.config.files. So basically what I'm trying to see here is what are the files associated with the virtual machine. So when I type in vmview.config.files, so that means I'm accessing the property called files of the property called config, which is itself a property of the virtual machine vmview. So if you look at the output here, it shows us the files which are stored on the data store for this particular virtual machine. And the fascinating part is that if you look at the output from your managed object browser, which is also another way of accessing your vCenter inventory at the API level, you see that the output is almost exactly identical. So if you see, compare the output for the vmview.config.files, and if you look down below at the managed object browser or the MOB output, you'll see that these two outputs are identical. So which just indicates that when we are working with view objects, we are accessing the actual the API details of the vCenter inventory. We are not really looking at an abstraction. We are looking at the actual low-level implementation of the API. Just to understand things a little better, we'll try to look at a few more examples. We have the view object called vmview, which we extracted earlier, and let's look at another property called summary. So I'm just typing in vmview.summary, and it shows me certain of the properties. This is a kind of a truncated output, and under this summary property, we see there is another property called runtime. So now I'm trying to access a sub property or a child property, if I may. So it is a vmview.summary.runtime. So I'm accessing this property called runtime, and if you look at the runtime output, it has a number of its own properties, and one of the properties is power state, and which basically indicates whether the virtual machine is powered on or off. So just to put it all together and to utilize this information, whatever we have gathered so far, we'll try to see if we can use this runtime property to filter the virtual machines which are powered on or off. So how can we do that? So we'll write a slightly longer and more complex command to accomplish this task. So what I'm saying here is get view, where the view type is virtual machine, and I use the term filter here, and using the property summary.runtime.powerState, I am going to try to compare with the value powered on. This will give me all the virtual machines which are powered on. So I hope you're able to understand the way things are rolling here. So basically I'm using a particular child property called a power state, which is a child property of runtime, which itself is a property of summary, and I'm using this property to find out the virtual machines which are powered on. So I hope you can understand that this can be very useful if you are trying to do some kind of complex scripting. Up till now we have been using this particular format for using the get view, where we say get view and we use the term view type to filter it by virtual machine. But there is an alternate syntax and an alternate way of doing it. So you can just go ahead and use this parameter called vi object with the get view. This is just another way of doing it. So here I'm saying get view using the parameter vi object, and I specify the name of the virtual machine JEOS_test1, and we get the same output which we usually get with the get view. So this is another alternate way of using the get view to find out information about an object using the parameter called vi object. So until now we have been using the get view command to pull out information about the view objects, which are the low level API objects. So let's see if there is any alternate way of pulling out the same information. So if we look at the original syntax of get view, it looks something like this. We do a get view, we specify the view type, in this case it's the virtual machine, and then using the filter parameter we specify the name of the particular virtual machine. Now we have another option of doing the same which does not involve using the get view. We can use the normal get VM commandlet, and we can pull out the same information. However, we have to use a particular property called the extension data. So let's look at the syntax of this extension data. So here I am saying get VM JEOS test1, and I'm storing the object in a variable called $VM, and then I just say $VM dot extension data, which is a very special type of property of the virtual machine, and then we try to look at the same properties which we did for the view objects, that is .summary.config, and let's see if this works for us. So if you see the output below, we have got the vm.extension_data.summary.config, and we are pretty much getting the same output which we might have got using the get view commandlet. So if you are not comfortable with the syntax of get view, or you want to use the get VM commandlet, then you'll have to use the extension data property, and it will give you the same API level detail which you get with the get VM commandlet. Now let's suppose that you want to perform some actions on a virtual machine or any other kind of object. So in the case of a VI object, which is a normal PowerCLI object which we deal with normally, we just say we just use a command called like start VM. So we take the VI object and pipe it into start VM, and so it will perform that operation on that particular object. However, in the case of view objects, so as I mentioned earlier, the view objects are the low-level implementation of the API. So that so in that case, those commandlets like start VM, stop VM, all those things are not applicable. So here we'll have actually we'll have to invoke the methods for that particular object. So that is the only way here. So in the case of a virtual machine, we have a method called power on VM. So that is a method of the virtual machine. This is a low level method. It is not like a PowerCLI commandlet. So this is an actual method of the low level API object. So let's see what happens if you by chance you're not aware of this and you try to execute a PowerCLI commandlet on a view object. So what will happen? So in this example, I am saying get view, and I have extracted a particular virtual machine called JEOS test1, and I've stored it in the variable called $VM. Now, please remember that this $VM is not a regular PowerCLI object, or it's not a VI object. This is a view object. So when we run the start VM commandlet on this object, which is a view object, we get an error naturally, as I told you that the normal commandlets will not work with the low level view objects. So what do we need to do here? So there is a solution to this. We use a conversion technique which is given by this commandlet called get VI object by VI view. So I know it's a mouthful. So it's get VI object by VI view. So if you use this commandlet, it is going to kind of in a way convert this view object into a normal VI object, and then you will be able to run the regular commandlets like start VM or stop VM. So let's take a look at this example. I am piping the view object into get VI object by view, and I am piping the same into a stop VM. So basically now it has been converted into a normal VI object, and I'm able to stop the VM using this particular commandlet. So just remember that if you want to use regular commandlets with the view objects, you will have to use get VI object by VI view. So as I mentioned earlier, we cannot be using the regular PowerCLI commandlets like start VM, stop VM, etc. on the view objects, because the view objects have a different kind of structure, and to perform any operation on a view object, we'll have to invoke a low level API method on that object. But how do you know which method to invoke, and how do you find out the methods of a particular object? For example, what are the methods associated with a virtual machine view object? So let's see if we can find out those methods. So first of all, what we do is I'm going to use the regular get view syntax to pull out the details of this virtual machine called myvm2_ubuntu. So I'm using this the same syntax which we have used earlier, that is a view type virtual machine and then filter with the name of the virtual machine. I'm taking the output and I'm going to pipe it onto the get member commandlet, which we have used many times before. And I'm just going to pipe it again into the where commandlet, which is basically a search mechanism, and I'm going to just look for the properties or the methods of this object. So I'll just say member type equals method. So please remember that we have to follow this syntax exactly when it comes to view objects. Now, if you look at the output here, you see that there are a number of methods which are showing up for this virtual machine view objects, and you'll have to remember that these methods are very much different from the methods which are associated with a VI object. So if you take the same virtual machine and look at it as a VI object, you'll see a different set of methods. But these are the low-level API methods, the low-level implementation, what we are seeing here. These are the methods which we see when we look at the managed object browser and actually try to look at the vCenter API directly. So if you want to invoke any of these methods, for example, in the case of a virtual machine, the most probably the widely used method to kind of invoke would be start VM or stop VM. So we don't have a start VM or stop VM method. The method name is called power on VM. So if you see the earlier screen, it's not there in this output because it has been truncated, but there is a method called power on VM and power off VM. So here I'm invoking the method power on VM on the VI object, and basically it also requires argument. So this is called an argument, which comes under the small brackets, and here the argument is nothing but null, so which means it does not require an argument to power on the VM. So once I run this command, I will use the get task to see whether the virtual machine is running or not, or that the task has been run or not. The task has been generated or not. So if you see the output on the screen below, you'll see that we have a task called power on VM, which is the recent one which we kind of invoked. And so this, if you look at the virtual machine, you'll see that eventually the virtual machine gets powered on. So once again, to reiterate this, we are not using the regular PowerCLI commandlets like start VM or stop VM here. We are invoking the method directly on the view object. So there is a lot of difference there, compared to using a normal VI object. So in this video, we kind of got an introduction to these view objects, and we saw how to use the the get view commandlet to take a detailed look at the view objects, which are the low level API implementation of these objects. Now there are certain scenarios when you are doing scripting, or maybe trying to stand up an environment, or maybe a new vSAN cluster using a script. And there are certain very minute tasks which are sometimes difficult to perform using the PowerCLI commandlets. So there might not be a PowerCLI commandlet available for that particular task which you are trying to accomplish. So in those scenarios, you might need to dig down and get an access to the properties and methods of that object using get view, and directly invoke the method instead of relying on a PowerCLI command. So in those scenarios, you will have to get yourself comfortable with the API, get yourself comfortable with using the get view commandlet, and it might prove to be very helpful to you in such situations. In this video, I am going to introduce you to vSAN automation using PowerCLI. So before I talk about any kind of automation with PowerCLI for your vSAN cluster, I'm going to just give you a brief overview of what exactly is vSAN, and what is the significance of vSAN in terms of being a software-defined storage solution. So what is vSAN? So vSAN is VMware's software-defined storage solution, which basically allows us to create a cluster of ESXi hosts. Like you can have a cluster of up to 64 ESXi hosts, and we can take the internal storage of all these hosts and form a shared pool of storage, which acts like a data store. So basically we are getting almost the same functionality which we get from a traditional storage solution, plus a lot of flexibility in terms of how we can manage that storage. So just to reiterate here, vSAN is basically uses only the internal storage of your ESXi hosts. So it does not have any reliance on any external LUNs, or it does not require any storage arrays. So it's a completely software defined storage solution. So let's look at a few of the key terms associated with vSAN or virtual SAN. So one of the important terms which we need to understand when it comes to vSAN is a disk group. So what exactly is a disk group? So disk group is a logical grouping of the disks inside a host. Now in your ESXi host, you might have a number of internally attached hard drives. So when you create a vSAN, you get an option of making a collection of these drives into a disk group. So a disk group is always has one cache device, and it can have up to 7 capacity devices or storage devices. So just to keep in mind, a disk group always has only one cache device, and in one host you can have up to 5 disk groups. So basically you have 7 capacity devices, which is the maximum per disk group, and per host you have 5 disk groups maximum. So these are the limits of the disk groups as of now. So let's then talk about the vSAN data store. So what exactly is the vSAN data store? So a vSAN data store for any intents and purpose is just like any other data store which we use in our vSphere environment, and all the hosts which are part of the cluster, they kind of pool their internal storage together to create just one data store. So a vSAN cluster always has one data store only. So that is one of the the features of vSAN, that it cannot have more than one data store. And so no matter even if your cluster is as small as 3 nodes or 64 nodes, it will just have one data store. So another key feature of this software defined storage is storage policies. In terms of since we are not using any RAID levels here, or we don't have the requirement to create LUNs with separate RAID levels, so how do you ensure that a virtual machine gets the performance it requires? So for example, you have a SQL Server virtual machine or an Oracle virtual machine. How do you make sure that it gets the performance which is required for that virtual machine? That is where storage policies come into the picture. So storage policies are basically will allow you to tailor the the performance to the requirements of that particular virtual machine. So let's see what are the characteristics of storage policies. So storage policies are based on storage capabilities. So obviously your policies will provide only the services which are there in the back end. So it will not it will not surpass the capabilities of the back end storage. Storage policies are defined for a virtual machine or disk at deployment time. So basically it means that you can apply a storage policy to a virtual machine or a VMDK itself. So it is that granular. It can be applied at a later time as well. So you have the flexibility of applying a storage policy or changing a storage policy at any point of time to a virtual machine. As I said, it can be changed at any time, and it cannot be deleted if the storage policies are in use. So it obviously makes sense. We cannot delete a storage policy if it is already applied to some virtual machines. So that is what about storage policies that we need to understand. And as I said, that there is no separate LUNs or RAID levels in vSAN. So everything is determined through the storage policies. Another important term is the objects in vSAN. So vSAN is a object-based storage. So basically what it means, that whatever components we store on vSAN, which can be VMDK files, VM swap files, snapshot files, everything is stored in the form of an object. So we can say that the objects are actually the containers for these the virtual machine components. So if you take a look here, what are the different kinds of files which are stored on vSAN? So you have the VM home namespace. A VM home namespace, even though the names sounds a bit new, but it is nothing but your VM home directory. So every virtual machine is stored in a home folder, which is actually the name of that virtual machine. So in the vSAN terminology, it is called the VM home namespace. And other than that, you have the VMDK files, the VM swap files, the snapshot delta files when you take a snapshot, and in case if you are storing taking the snapshot with the memory option selected or saving the memory, then you'll have those the VM memory files. These are the different types of virtual machine files which are represented as objects in virtual SAN or on the vSAN data store. And so this is what we were referring to in the previous slide. When we look at a VMDK file, it is nothing but a object on the vSAN data store. So it does not appear as like a VMDK file. It's referred to as an object. Another key feature of vSAN is the vSAN health service. So vSAN is very proactive in terms of reporting errors. So this the health service actually enables you to find out if there is anything wrong with the vSAN cluster, if the networking is fine, or if the disks are all healthy. So everything is reported by this vSAN health service. So it's a very useful feature of vSAN. So in case if you get into trouble and are not able to find out what exactly is wrong with the vSAN cluster, or if you have some kind of network partition issues, the first place to look at is the vSAN health service, which will help you troubleshoot and then hopefully fix the problem. Okay, so finally talking about the automation part of vSAN. So in this video, we kind of want to talk about automation using PowerCLI. So using PowerCLI, you can automate almost all the, or I should not even say almost, you can automate every aspect of your vSAN cluster. So just as an example, here are the few of the things which we deal with when we work with vSAN. For example, your virtual data center cluster, adding hosts to a cluster, your host configuration, iSCSI configuration for your vSAN, your switch configuration, NIC teaming policy, enabling virtual SAN, claiming the devices, creating disk groups, or enabling or disabling deduplication or space efficiency features. Everything can be taken care using the PowerCLI commandlets. So in terms of automation and the utility of PowerCLI for automatic vSAN, you can perform everything which is possible from the graphical user interface. Just to take an example of few of the tasks, and this is not an exhaustive list, this is just a few examples which are the commonly performed tasks using PowerCLI. So one is you can enable the vSAN cluster using PowerCLI commandlets. You can create disk groups. You can check the vSAN HCL. You can test vSAN cluster health. So there is a separate commandlet for that. You can get detailed information about the vSAN disks. So there is a command called get vSAN disk, which actually gives very, very detailed information about the vSAN disks. You can perform iSCSI configuration. So there is a set of vSAN related iSCSI commands in PowerCLI, which will help you configure the iSCSI settings in vSAN using PowerCLI commandlets without doing anything from the graphical user interface. You can create fault domains, delete fault domains using PowerCLI, and you can perform many other tasks. In fact, every possible kind of administrative task can be done using PowerCLI for vSAN. Just to give you a taste of what exactly, what are the commands available for vSAN, the PowerCLI commands which are available. I'm just going to run this simple command called get command, and I'm going to search for the keyword vSAN. So I'm just basically trying to see what are the commandlets which contain the word vSAN, and as you can see there is a huge number of commandlets. So this is again a truncated list. There are some more commandlets down at the bottom which I've not been able to list here, and there are also commandlets for SPBM, storage policy based management, which is not in this list. So as you can see, there is a huge number of commandlets which are available for performing any kind of administrative tasks with vSAN using PowerCLI. In this video, I am going to talk about a very common automation scenario using PowerCLI for vSAN clusters, and this is about reporting information for your vSAN clusters. So let's take a very common use case. So suppose we have this company. I'm taking a fictitious company A here, which has deployed a number of vSAN clusters across its various regions, and now there is some requirement from their management to provide some reports on that vSAN clusters or those vSAN clusters. So there are some requirements for this reporting, which are the report should show the settings of the vSAN cluster. So the management wants to know whether the settings on the vSAN clusters are optimal, or if any of the vSAN clusters have the wrong settings. So the management needs to be aware of that. This report should be available in different formats. So the management might want the report in different formats like CSV or HTML based upon their requirements. And also there is a requirement for this report to be sent at regular intervals like daily, weekly or monthly. So this is the scenario which is given to us, and now our job is to try and solve this issue by performing some kind of automation using PowerCLI, or writing a script which is going to meet these requirements. So one of the first points which we need to figure out is which are the PowerCLI commands related to vSAN which are going to be useful to us for generating this kind of report. So we have this PowerCLI commandlet called get vSAN cluster configuration. Now if you once we run this command, you will pretty much get a complete overview of the settings of your vSAN cluster. So in the coming slides, I'm going to show you how to use this commandlet to find out the different settings of the vSAN cluster. And after you have those data with you, then it is relatively easy to script those into a kind of a PowerCLI script, and generate the output in different formats using commands like with the HTML view command or out CSV command. So there are various commandlets available which will produce the reports in the required formats. So but it's very important to know how to use the get vSAN cluster configuration commandlet, so that we can pull out all the important information about the vSAN cluster. So before we can do anything with the PowerCLI commandlets for vSAN, we need to find out the object for the vSAN cluster itself. So for that we run this command called get cluster, and we provide the name of our vSAN cluster. So in my lab environment, the name of the vSAN cluster is vSAN-cluster. So what I do is get cluster minus name, and I give the name of the cluster, and I store it in a variable called cluster. $cluster is the variable name which now stores the information about my vSAN cluster. So this is the variable which stores that object. Now before we can do anything else with this commandlet which I talked about, we need to know what are the properties and methods which are available for that commandlet. So for doing that, I am running this command get vSAN cluster configuration, and as the parameter I have supplied the cluster object, and I am storing the results in this variable called vSAN config. So the vSAN configuration is now stored in vSAN config variable. If you pipe the vSAN config variable into a format list, you will get a complete picture of all the settings related to your vSAN cluster. So if you look at the screen here, you can see that we can see all the settings. For example, space efficiency enabled, or performance service enabled, or the silent health check. So all these are settings which are pertaining to the vSAN cluster, and this one commandlet gives you the view of the entire settings in one shot. So this is one way of pulling out the report. So this is one way where you can generate the report about the configuration of your vSAN cluster. However, if you want to kind of customize this report in a different way, or maybe your script requires you to pull out these settings one by one, so there is a way to do that. So here I am looking at the different properties of the vSAN config variable, which stores the properties of that cluster. So here I am looking at three properties. One is health check enabled is one property. The another property is performance service enabled, and the third property which I want to look at is the vSAN disclaim mode. So one by one, if I run these commandlets, you will see that the health check enabled is marked as true, and the performance service enabled is also true, so which means the performance service is indeed enabled, and also the disclaim mode is set to automatic. So as you can see that the get vSAN cluster configuration basically gives you all the information you can need about the vSAN cluster, and you can manipulate that information in any way you want. You can pull out the information, and you can automate that using a script, and probably try to generate a report in the CSV format or an HTML format. So the key point here is that we need to be familiar with this get vSAN cluster configuration command to be able to pull out this information. So that is one of the very useful commands for the vSAN cluster configuration. Let's take a look at some other commands for the reporting purposes. So there is one more case which we need to look at. So there is another requirement for the same company, and this time the management wants some information about the health state of the vSAN cluster. So for example, they want a report which should indicate whether the vSAN cluster is fully supported, it is functional and operational. So it's very important to know whether that vSAN cluster is operating at the most healthy state, or whether there is any kind of disk failures or network failures. Anything like that must be reported to the management, and that report should be of course be available in different formats like CSV and HTML, and it can be automated to send daily, weekly or monthly. So to generate this kind of report, again we have to narrow it down to some vSAN commandlets which are or the PowerCLI vSAN commandlets which are going to produce the appropriate result. So now we know that there is a commandlet called test vSAN cluster health, which is going to provide us with most of the information which we need. So in the next few slides, I'm going to show you how to use the test vSAN cluster health commandlet to pull out the health information about the cluster. So let's take a look on how to use this particular commandlet. So to do the test vSAN cluster health, it is relatively simple. You just run this command test vSAN cluster health, and you as a parameter you pass in the cluster object. So this will give you since I am running this command without any other parameters, it is giving me a very brief description about the health of the cluster. So if you look here, it says the name of the cluster, overall health status is failed, and overall health description is network misconfiguration. So it might be possible that on one of the ESXi hosts, somebody has disabled the VM kernel NIC, or there is some other kind of failure on one of the ESXi hosts. So it is obviously showing a network misconfiguration. So let's try to see if we can get some more information on this. So now let's try to see what kind of information we can pull out about the health. Again, to find that, we need to know what are the properties which are available for that particular object, that is a vSAN health object. So what I'm doing here is I'm running the test vSAN cluster health. I'm going to store the result in a variable called vSAN health. Once I store the result in vSAN health, I will pipe the output onto get member. So as we know that get member will actually show you what are the methods and properties associated with a particular object. So since I am passing the vSAN health on to get member, we get a number of properties. So as you can see, all the vSAN health related properties are available here. For example, CLOM liveness or CLOMD liveness, create VM health, disk balance. A huge number of properties are available indicating what are the health issues with the cluster. You can narrow down and find out which properties you are interested in. So for example, in my case, I just ran I'm just looking at the property overall health description. So I just type in vSAN health dot overall health description. It gives me a description saying physical disk issue. So if you just want to know at the overall level what is the issue, then it is better to run this command. It will give you an idea of what is wrong, whether it's a network issue or a disk issue or both of those. Second, we can also look directly at the network health. So we have a separate property called network health. So here I'm running vSAN health dot network health. So network health property will provide detailed information on the network tests which were performed. So if you look at the output down below, you can see that it has performed the network test, and whatever issues found, if there are any issues, they will be highlighted. So for example, in my case, it says issues found as false, and it has a number of other parameters which indicate what are the other tests which are performed. So as you can see that using the the vSAN health object, we can pretty much generate a report about any health issue. In this video, I am going to focus on how to use vSAN commandlets or vSAN PowerCLI commandlets to make certain configuration changes on your vSAN cluster. So most of the settings of the vSAN cluster can be altered or controlled using the PowerCLI command.